now we're going to cover the topic of standing waves, and we'll go over the theory. These are two waves that are, one is coming one way and the other wave is coming the other way, and we're going to create a situation where they sometimes cancel each other and sometimes they constructively interfere, and we're going to analyze what happens. And this topic can be applied to the topic of standing waves in strings and standing waves in pipes with one open end and one closed end, or pipes with both open ends, right? So we're going to analyze this wave y1 as a function of x of t. That's equal to a sine of kx minus omega t. And then y2 is equal to a sine of kx plus omega t, right? So in this case, the only difference between them, they are both going at the same frequency and same wavelength, but one is moving to the left, this y2, and then y1 is moving to the right, right? So how are they going to combine? Y total x of t, so a, then it's going to be, so we're going to say y total is going to equal 2a, then we're going to say cosine of kx minus omega t, then we're going to subtract from there kx plus omega t, and then divided by 2, and then sine of kx minus omega t plus kx plus omega t divided by 2, right? So what's going to happen here? Y total is equal to 2a cosine, the kx and the kx will cancel, negative omega t is going to be negative 2 omega t divided by 2, and then over here you're going to have sine of, and then negative omega t is going to cancel the positive omega t, right? And then kx plus kx is going to be 2kx over 2, right? And then earlier we mentioned already that the cosine is an even function, so then this negative doesn't matter. And then the 2 cancels the 2, and then this 2 cancels the 2, and then we get this equation. So this is the equation of what's known as a standing wave. So let's analyze this equation. So you have here y total x of t is equal to 2a. I'm going to write the sine kx, and then we have cosine omega t. Now one thing we notice in this equation is that it is not a traveling wave. In order for a wave to be a traveling wave, it needs to have this form. A sine of kx minus omega t. In other words, the kx and the omega t need to be in the same parentheses, in the same trig function, right? You basically have, in this case, cosine omega t. So this tells you the time change of the wave as a function of time, and then this tells you the amplitude of the wave. So this whole thing is just basically the amplitude. So all you basically have is a wave that is propagating up and down as a function of time, but its amplitude is changing, right? What does this mean? If kx is equal to what? 0 or pi or 2 pi, what's going to happen? The 0 pi, 2 pi, 3 pi, sine of 0, sine of pi, sine of 2 pi, sine of 3 pi, that's equal to 0, right? So at those points, the wave is always going to be basically standing still. It's not going to move up and down as a function of time. So imagine that this is a string like this. This is 0, 0, and then the length of the string is L0, right? So at which points is the wave going to be standing still? We have kx, how can we generalize this? N pi, where n is 0, 1, 2, 3, 4, so on, right? So x is equal to n pi over k. So if x is equal to n pi over k, then you're basically, the wave is going to be standing still. Those points are called nodes of the wave, right? The other way that we can write this is that, remember, k is the wave number, and it's equal to 2 pi over lambda, right? So we can write over here 2 pi over lambda, n pi, 2 pi over lambda, and then the pi and the pi cancel, then we get here n lambda over 2, right? So when at positions that are integer multiple of half their wavelength, right, you're going to have destructive interference. The incoming wave and the outgoing wave is going to cancel each other, right? So the wave looks something like this, let's say. Then it's propagating then let's say this is the end of the string, then it goes like this, right? These points are called antinodes, where it has maximum of oscillation up and down, right? Antinodes. And then these points are the nodes. The nodes. So what points will cause nodes? The nodes will be those points where the incoming and the outgoing wave are always canceling each other, right? It's not oscillating up and down. So this tells you the position along the x-axis where the nodes will always occur, right? Nodes. So that means complete destructive interference. The place of the antinodes where maximum oscillation occurs, right? So what would that be? If kx is equal to pi over 2, right? If this is pi over 2, then the sine of pi over 2 will be 1, and the amplitude will be 2a. So that means it's double the amplitude of the incoming and outgoing waves, right? So there was originally a certain wave of a certain amplitude, then reflected back, which both had amplitude a. This one is 2a, right? The distance between here and here is 2a. 2a. So it's doubling the amplitude. That's the place of the antinodes, where the two waves are constructively interfering and they're basically vibrating up and down, right? So what is this telling you? If this one is 1, so basically what will happen? Y total is going to be 2a cosine omega t. That means that this point of the wave is not going to be stationary. It's not going to be standing there. It's going to be oscillating from a maximum of 2a. Then it's going to be going downward, 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 all the way down to negative 2a, and then all the way up to 2a, and then all the way down to negative 2a, right? So that's the point we call the antinodes, right? So the requirement for antinode is kx is pi over 2, or 3 pi over 2, or 5 pi over 2, and then so on and so forth like that, right? So how can we generalize that then? N plus a half times pi, where n is equal to 0, right? N equals 0, 1, 2, 3, 4. And we can put here k is equal to 2 pi over lambda. And then the pi cancels, and then we have here x is equal to n plus a half times lambda over 2. If you put here n is equal to 0, you're going to get lambda over 4. Next, I'm going to put n equals to 1 in here. 1 plus a half, that's going to be 3 halves times lambda over 2 over 4. Right? And then if you put n equals to 2, you're going to get 5 halves times lambda over 2. You're going to get 5 lambda over 4. So 5 lambda over 4, 7 lambda over 4. So the other way that we can write this equation, n plus a half lambda over 2, where n is 0, 1, 2, 3, 4, we can just say x equals to n lambda over 4, where n is equal to 1, 3, 5, 7, 9, so on, so on, so on, the odd integers, right? Either way is acceptable. Either n plus a half lambda over 2, 0, 1, 2, 3, 4, or you can write n lambda over 4, n equals 1, 3, 5, 7, 9, odd integers, and then these are places where the antinodes will occur. And the antinodes, as we said, is the place where the maximum oscillation will occur between 2a and negative 2a, right? In the next video, I'm going to apply this in particular to the concept of standing waves in strings with the two ends fixed, the left end and the right end, and then we're going to apply it to pipes, both sides open, both sides closed, and then one side open and one side closed. Thank you very much.